5. So these say factor each polynomial. So some of this we've seen before, some of we haven't. Factor, remember what are factors? What are factors of numbers? Like if I said what are the factors of 16, what is that? 4, 2, 8, 1, and 16, right? Those are factors. What are factors? And numbers that are multiplied together to give you this number, right? Right? 8 times 2 is 16. 4 times 4 is 16. 1 times 16 is 16. Those are factors, right? So we're factoring polynomials now. So we're writing what times what gives us this, in this case, this binomial. Okay? And the first thing we always look for is a GCF, and GCF again stands for what? Greatest common factor, right? And we're going to undo the distributive property. We're going to take the GCF, we're going to pull it out, and we're going to rewrite what's left over. So in this binomial, what's the GCF here? What do both these have in common? What factor? A 7, right? So we pull out a factor of 7, okay? And then we rewrite what's left over if we undid the distributive property here. So I'd be left with x plus 7, right? That way if I redistributed this, I would get this back, okay? So this would be my factored form. This monomial, which is just a 7, times this binomial would give me this binomial, right? So that's what I want you to do on the first 5 here, and then we'll check our answer together. So this is stuff we did a couple classes ago. Do the first 5. I want you to factor out the GCF and rewrite what's left. Okay, hopefully pretty straightforward here. What's the GCF on number 2? 2, right? Just have a 2 in common. So what's left would be a 4m minus 3, right? If I factored out that 2, again, you can check your answer by redistributing. Okay. Number 3, what's the GCF there? Just a 5, good. So you'd be left with a squared minus 3. If you redistribute there, you get that binomial back. Number 4, what is the GCF there? 5 and a q, right? Between 10 and 25, the GCF is 5. The first term has 1 q. The second term has 2 q factors. So in common, the most they have in common is 1 q. So if I factor out a 5q, I'm going to have a 2 minus 5q there. Right? Redistribute, that'd give me 10q minus 25q the second. And the last one, number 5, between 8ax minus 56a. So first, just between 8 and 56, what's the GCF? 8, right? They're both divisible by 8. They both share an a, but only the first term has an x, so 8a is my GCF. Right? Which is going to leave me with what in my first term? Just x minus 7 there. Good. So there's the first 5. Again, that's old stuff we've been talking about. Any questions there? Okay. Try 6 through 10 now. They're also going to be similar, except you have a couple trinomials in there, which still looking for a GCF, but you want the GCF between all 3 terms and not just 2 of them like in a binomial now. So I'll give you a second to try those, and then we'll check answers. Number 6. So let's just look at the numbers first, the coefficients, 81 and 48. So I want a GCF between those two things. So, 81's not even. All even numbers I know at least have a common factor of 2, but I'm looking for the greatest here. Anybody come up with the greatest common factor there? 81 and 48? It's 3, right? It's 3. Seems like there might be a bigger one, but there's not. Now, even if you got it, a calculator might have been helpful. Anybody remember how we could find it out if we were really unsure if it was 3 or not? You did on the previous homework. Remember the prime factorization, where if you take 2 numbers and you factor them all the way, like using a factor tree, you can see what they have in common, right? So like an 81, I could factor into 9 and 9, which would be 3 and 3, and that would be 3 and 3. So 81, the prime numbers that make it up are 3 times 3 times 3 times 3. 48, if I did the same thing, let's say 12 and 4, that's 2 and 2. Let's say that's 6 and 2. That's 3 and 2. So it's 3 times 2 times 2 times 2 times 2, right? The only thing they share, the only factor they share is 3. Right? If they shared more of them, I would do the greatest, and I'd multiply them together, but that's the only one they share. So if you're really unsure, you can always do the factor tree and see what they have in common. Okay? But 3 is the greatest, okay? And then what variables? Just an r, right? So I factor out a 3r from 81r. What am I left with? 27, good. Plus 48, divided that by 3, 16t. So that'd be my answer, right? This monomial times this binomial would give me that binomial, right? All right, number 7. So it's a 1, t to the second h plus 3. So there's no common factor there. What's the common factor variable? Just a t, right? So just a t. So I'm left with t h. So I still have a t in the first term. I had 2 of them. Now I only have 1 plus 3. Number 8. What's the common factor between those two terms? A. Good. So I'm left with a to the first, b to the second. And again, the most common mistake I see in these problems is then people will stop right there. And that would be incorrect, right? Because if you remultiply these together, you don't get that binomial. Instead, what should go at the end of my binomial here? Plus 1, right? Because if you redistribute that, okay, you divided that a by a, which gives you 1. There's a 1 there, okay? So you should have plus 1 there. All right. Number 9, okay? Now you have a trinomial, so you're looking what's in common of all 3, and that would just be an x, right? So in the first term, again, I'm left with 1, and then I have plus xy, then I have plus x to the second, y to the second. Right? My y variable stayed the same. I just factored out an x from all 3 terms. And last one, number 10, here, another trinomial. What's the common factor? Just a p. So I'm left with 3 p to the second. Or sorry, there were 2 p's, right? So I'm left with 3 p to the first. Okay. R to the second plus 6r plus 1. Okay. Any questions through those first 10? Just factoring out a GCF, undoing the distributive property here. All right, let's do these last 2 that are trinomials together, and then we run into something different. Okay. Number 11, you have 4a to the second, b to the second, plus 16ab, plus 12a. So I have a trinomial. I'm looking at what's in the greatest common factor between these 3 terms. Between 4, 16, and 12, what's the GCF? 4. Okay. They all share an a variable, right? So I can bring out an a, but they don't all share a b variable, right? That last term doesn't have any, so I can't pull out anything but the greatest common factor, so just a 4a is my greatest common factor. I can't pull out a b because of the third term. So in the first term, I'm left with a to the first, b to the second. Again, just double check if you remultiply those together, you should get that. Right? That was the last test, was how do you multiply those things together. Okay, this one we're working backwards. I pulled out a factor of 4 from this 16, so what am I left with? 4. I pulled out that a, so I still have that b. Pulled out a factor of 4 from the 12, so I'm left with 3. And I pulled out that a, so that would be my final answer. This monomial times this trinomial would give me this trinomial. And the last trinomial here, number 12. We have 10h to the third n to the third minus 2h n to the second plus 14h n. Trinomial again. 10, negative 2, and 14. What's the GCF in those 3? Just a 2. They're all even. I have h to the third, h to the first, h to the first, so the most they all share is just an h. I have n to the third, n to the second, n to the first, so the most that they all have in common is just one n. So 2hn is my GCF. That would leave me with 5, h to the second, n to the second, because I pulled out 1 from each, minus, pulled out that 2, so I'm left with 1, h, n, so just an n, right, because I pulled out one of those n, plus 7, I pulled out both that h and the n, so that is my factored form. Okay. And that's just a quick review of what we've talked about up to this point. Any questions with those? Anyone we want to double check again? So I'm going to skip 13 a second. I want to look at 14. Okay, we'll come back to 13. 14 looks like this. It says b to the second minus 2b plus 3b minus 6. So there are 2 main differences with this polynomial and the previous ones we were just doing. Somebody give me one of them. What's one difference between this one and the other ones? Yeah. Right, there's no GCF in this one. What's the other difference between this one and the previous ones? Yeah.
There's 4.
Yeah, there's 4 terms, right? There's 4 terms and there's no GCF, right? The other ones we either had 2 terms or 3 terms. This one has 4 terms. So that's a problem, right? We want to figure out what binomial times a binomial would give me this 4-term polynomial, okay? Whenever this is the case, which this is the case on numbers 13 through 18, I think, okay? Whenever this is the case, we have a special method we have to use. Whenever there's no greatest common factor, and whenever there's 4 terms. And you probably haven't seen this before, maybe you had, but it's called, we're going to factor by grouping, okay? It's a different method, right? Previously, we've just been looking, what's the GCF? We found the GCF, we pulled it out. This is factor by grouping. You only do this thing called factor by grouping when there's no greatest common factor and there's 4 terms, right? You could pull out a 1 here, but that's not going to help us in the long run when we start solving these problems instead of just factoring them, okay? 1 is the only thing in common. So when there's no greatest common factor, when there's 4 terms, we do this thing called factor by grouping. Okay? Factor by grouping is a very procedural thing. Like you do the same thing every type of problem, you just have different numbers. So the first one might take a minute, but hopefully by the time we get through a couple of them, you feel all right with factor by grouping. So all right, so we recognize this one's 4 terms, no greatest common factor. So this is how we group them. Okay, we're going to group the first 2. And by group them, I'm going to put parentheses around them. We're going to group the first 2, and we're going to group the second 2. Okay. So let's just look at the first 2 that we grouped. What's the greatest common factor in these 2 terms? Just a b, right? So if I pull out a common factor of b there, and write what's left over in that first grouping, I have b minus 2. Everybody agree with that? Okay. The second grouping, what's the GCF in the second grouping? A positive 3, right? And I'm going to have you write a positive 3 or plus 3. I would not just write 3 because what's the problem? What's this look like if you just write 3? Looks like you're reverse distributing or multiplying here, right? So make sure if you pull out a positive or negative, you write plus 3 here. You'll see why in just a minute. So we're going to pull out a positive 3 here, which is going to leave us with a b minus 2 there. Which then, if you look, what's in common between these 2 things? A b minus 2, right? So we're going to kind of factor out again a b minus 2. And the other binomial that makes this up, or the other factor, is whatever is left over that was factored out, which is b plus 3. So this binomial times this binomial gives me this. Okay? One of the binomials is always going to be the same, which it should be here, and the others is binomials, whatever you factored out. Let's check our answer on the whiteboard here. I'll do this on the sideboard so I can keep this up. So up on the board I have b minus 2, we would call each of these the b minus 2 and the b plus 3 is a factor of this because that times that gives you this. Right? So you only do this process when there's 4 terms and no GCF, this grouping. Okay. All right, let's try 15. Again, we're going to come back to 13. I'm going to write down 15 here. 15 says 2j to the second plus 2j plus 3j plus 3. Thank you. 4 terms, no GCF among all 3, so we got to group it. We're going to group the first 2. We're going to group the second 2. We're going to look for a GCF in the first 2. What's the GCF in the first grouping? A 2 and a j, right? Factor that out, so I'm left with j plus, and what goes here? 1, because I've pulled all of that out, right? What's the GCF in this second grouping? Just a positive 3, so I'm going to pull out a positive 3. Remember, I'm going to write plus there so I don't confuse that with multiplication. And I'm left with j plus 1. Remember, you should always be able to re-multiply this back together and get this, right? So we should look, you should always have one of the binomials is the same in both of these parts. If it's not the same here and here, one of 2 things happened. Either you did something wrong in the previous step, or you can't factor this polynomial, right? And just like when we have like a number 3 that only has factors 1 in itself, what do we call numbers that only have factors of 1 of itself? Prime, right? It's possible to have a prime polynomial. None of these are, but it's possible, right? So if these two things aren't the same, there was either a mistake or it's prime, and you can't factor any further, and you would just leave it like this. But one of the binomials that make it up is what's in common. The other binomial that makes it up is what you factored out, which in this case is 2j plus 3. So again, that's my answer, because I'm looking for the factored form. I'm looking for the binomial times a binomial that gives me that. Does that make sense? All right. I would like you to try, let's see, we did 14 and 15. Skip 16 and 17, try 18, because there's one little different thing than those. Try 18 yourself here, and we'll check answers. So there's 18 here. 4 terms, no GCF. We have to group it. Let's group the first 2 terms, group the second 2 terms. GCF between these 2 things is what? 3 and an x. So I'm left with 3x minus y. All right, when I factor that, pull that out. Here, GCF between these 2 things, just a 2, right? Positive 2 leaves me 3x minus y, which that's good. Because remember I said these things have to be the same. So that's one binomial of your answer is what's in common, what 3x minus y. The other binomial, 3x plus 2, what you factored out. Okay. Again, the order of these binomials doesn't matter because if you multiply them together, obviously you're going to get the same thing back. Okay, either way. So this binomial times this binomial gives me this. Okay. All right, let's quickly go over the other ones I'd skip. Number 13. 13 says x to the second plus 3x plus x plus 3. Okay. 4 terms, no GCF, so let's group it. Group the first 2, group the second 2. GCF in the first grouping is just an x, so I'm left with x plus 3. What's the greatest common factor in the second one, though? Just a positive 1, right? Everything always has a factor of 1. So that's the only thing they share. So I'm going to pull out a positive 1, which still leaves me with x plus 3 there. If I redistribute that 1 back, that's what I get. Okay. So one binomial of my factored form is what's in common. The other binomial of my factored form is what I factored out. So it's x plus 1 times x plus 3 would give me this. Again, you can always check your answer. If you redistribute both those things, you should get that back. So sometimes there's no GCF and you just have to pull out a 1. Okay. All right, do number 16 real quick. We'll do 16 and 18, and that'll be it. We'll take a short break with grouping. I'll work it out up here. You can check your answer as you go. I'm going to pull out a GCF, or I'm going to group them. Group the first 2. What's in common is a 2t. That leaves me 3t minus 2. Group the second 2. What's in common there? Just a 1. So if I pull out a positive 1, I'm still left with negative 3t plus 2. But there's a problem here, right? These 2 things are not identical, right? This is a negative 3t plus 2. This is a positive 3t minus 2. They're close but not identical. That means I can't continue. But since this is so close, how could I make this just like this, 3t minus 2? What about if I didn't pull out a positive 1, instead I did what? You could pull out a negative 1. Okay. You can pull out a negative 1. All right, so let's pull out a negative 1 instead. You pull out a negative 1, this is going to give you a positive 3t then. And remember, a negative times negative gives you positive. 2 negatives make up a positive. So I'm left with minus 2 there, which now those are the same. That makes sense? Again, if I redistribute that, that's what I would get. So I'm going to pull out a negative 1 there instead of positive 1. So then what's in common is one binomial of my answer, 3t minus 2. And what I factored out is the other binomial, 2t minus 1. and that's my factored form. This binomial times this binomial gives me this polynomial. Before we jump to the bottom section, starting with 19 here, what could you plug into the blank here that makes this equation true? You could plug in anything, right? It doesn't matter what you plug in here, this equation is true. Why? Good. Anything times 0 is 0, right? Doesn't matter if it's a fraction, a decimal, an integer, anything times 0 is 0. Right? So it doesn't matter whenever you have an equation equal to 0, only one of those things needs to be 0 for the whole thing to be 0, right? So let's jump to this problem on 19. Now they actually factored 19 for you already, right? The original problem, if I was to redistribute this back, the original problem would have been something like x squared minus 8x equals 0. Okay? And it wants us to solve for x now. So now not only are we factoring, which they did for us here, we want to actually get an answer, a solution for x. Okay, x equals this. So I have a multiplication here. I have a monomial, that's my monomial, times a binomial, right? And since it equals 0, only one of these two things has to be 0 for the whole thing to be 0, right? If both are, great, but only one of them has to be. And there's actually two solutions to this problem. Does anybody know, I don't expect you to know this, but does anybody know how I know before this problem starts that there's actually two solutions and not just one? How do I know there's two solutions and not just one? Think here. What degree is this binomial? It's a second degree, right? That has a second degree, that has a first degree. Whenever you have one variable, the degree is going to tell you how many solutions there are. So there should be two answers for x in this problem. Two things that you could plug in for x that make this true. Okay. First, this monomial. What would x have to be for this to be 0, this monomial? Don't think too hard. It'd have to be 0, right? If x is 0, let's test our answer. That means I plug in 0, there, and there. Is that going to come out to be 0? Well, let's simplify the parentheses first. You could distribute if you want. But let's parentheses first. That's going to be negative 8. And 0 times negative 8 is 0. So that works, right? Because one part of the multiplication problem is 0. The whole thing's 0. So one of my solutions is x is 0. That's when the monomial equals 0. What do you think the other solution is going to be? What does x have to be for this to be 0? It would have to be 8, right? If x is 8, let's see what that does in this problem. I would give me 8 here. 8 minus 8, is this going to work out to be 0? Because it's 8 times 0, which is 0. That's true. So those are my two solutions. One of them is when this part of the multiplication problem is 0. The other one is when this part of the multiplication problem is 0. So the two solutions for this are 0 and 8. Right? Because if I go check my answer here, 0 squared minus 8 times 0 is 0. And 8 squared, that's 64, minus 8 times 8, that's 64, is also 0. Again, they factored this for us. This would have been the original problem here. So this is how factoring can help us solve more complex equations, right? We couldn't solve this equation up top except for being able to factor. They're not like terms. You can't combine them. You can't just get x by itself. All right, so 20. 20 says b times b plus 12. Again, this is one they already factored for us. The factoring's been done. There's two solutions to this problem. One of them is when this part of the multiplication problem is 0. I don't care what the other part would be because one part needs to be 0. And one part is when this part of the multiplication problem is 0, right? Because I have a monomial times a binomial. What would b have to be for this part of the multiplication problem to be 0? 0, right? That's one solution. If you plug that in, that becomes 0 times 0 plus 12, which is 12. 0 times 12 is 0. What would b have to be for this to be 0? Negative 12, right? If you plug in negative 12 here and here, you're going to get negative 12 times 0, which is 0. So those are my two answers, right? Easy enough. I know there's two solutions here. It doesn't matter which part is 0 because the whole thing will be 0 when they're multiplied. All right, try number 21 and 22 yourself. They've already been factored for you. They've already done the factoring. 22 is a little more difficult, but see what you can do with these two. I'll give you a second and we'll check answer. So first one here, now it's a binomial times Right? Binomial times binomial. Again, only one part of the multiplication problem has to be 0. The whole thing's 0. What value of m makes this part 0? 3, right? If I plug in 3, that's going to be 0 times 8, which is, of course, 0. And what about this part? Negative 5, right? Because if I plug in negative 5, that's going to be negative 8 times 0, which is 0. So that's true. Now, this is good, right, that it's equal to 0. If this was 1 right here, this problem would suck, right? Because I don't know what I could plug in for m to make this 1. I would have to guess and check, and there's other ways to do it. But for right now, okay, that would not be easy. We always want them equal to 0, because anything times 0 is 0, right? Or if this was any number but 0, it would be much worse. But as long as this number is 0, it makes it much easier for us. Okay, 22 is the same case. Okay. Here, binomial times a binomial. What value of a would make this 0? 9, right? Now this one's a little tougher. Now you may or may not be able to do this one in your head, but let's assume we can't. We're stuck. I don't know what I should plug in for a here that would make this 0 and make this equation true. Okay? If that's the case, just write this out. I want to know, when does 2a plus 1 equal 0, right? And I can solve this equation for a like we did last semester, right? Just solve this for a. Subtract 1 from both sides. 2a equals negative 1. Divide both sides by 2. And the answer is negative 1/2, right? So if you plug in negative 1/2 here, well, half of 1 is, or half of 2 is 1, and negative is negative 1 plus 1, which is 0. So whenever this is not as easy as a minus 9, just write out, okay, when does this binomial equal 0, and solve for that variable. Because sometimes you get a fractional answer. So the two solutions of this problem are 9 and negative 1/2. Both of those would make this true. Okay, it would make that equal to 0. All right, so now we get to the last 4 where they're not factored for us. 23. You have x to the second minus 5x, and it's equal to 0. So it's equal to 0, that's good. Okay, but this part's not factored for us. All right, this is a subtraction problem. You got multiplication here, but this is a subtraction problem. I want to factor this. I want to write what times what gives me this. So it's just a binomial, so I want to look for a GCF. What's the GCF between these two terms? Just an x, right? Just like we did up above in the first 10 problems. X is all that's in common. That's going to leave me with an x minus 5 left. Right? I undid the distributive property. Now I made it so I have a monomial times a binomial. Right? So again, it's multiplication. I only need one part of that multiplication problem to be 0 for the whole thing to be 0. And again, I know there's two solutions to this problem because of that. There's two solutions for x, two answers x can be. One of them is when this monomial is 0, which what's x have to be for that to be 0? Here, 0, right? If this part's 0, I don't even care what these parentheses are, because 0 times anything is 0. It would be negative 5, but I don't care. What about the yellow, the binomial? What would x have to be for that to be 0? Just 5, right? Because then that's going to give me 5 times 0, which is 0. So my two solutions to this problem are 0 and 5. If I check my answer, you know, I plug in 0 here and here. 0 squared minus 5 times 0 is 0. Plug in 5. 5 squared. That'd be 25 minus 5 times 5, which is 25 is 0 too. Okay. 24, factor this, solve for y. Greatest common factor between these two is a y. So pull that out. My two solutions, when that is 0, y would be 0. When that is 0, y would be negative 3. Those are my two answers, 0 and negative 3. What's the difference between this one and the previous ones? It doesn't equal 0, which is a problem, right? I don't want to deal with these when they don't equal 0. So let's make it equal 0. We want to move this term to the other side of the equal sign. Since it's a positive 6a, how do we move it over? Just subtract it from both sides. Minus 6a minus 6a. Let's rewrite what we have left now. So I have 3a to the second minus 6a, and then it's going to equal 0 because there's nothing left on that side. And then I'll continue like the previous ones. I'm going to factor, and then I'm going to find my solutions. What's the greatest common factor in this binomial? 3a. That leaves me with a minus 2 equals 0, right? So now I have a monomial times a binomial. I need one of those things to be 0 for the whole thing to be 0. Again, there should be two solutions because of this. Now this 3a, or 3 times a, what would a have to be for that to be 0? Still just 0, right? Because 3 times 0 is 0. Right. What would a have to be for the binomial? 2. So 0 and 2 are my solutions. You know, if I recheck my answer, that'd be 0 equals 0, which is true. 2 to the second power would be 4. 3 times 4, which is 12. Well, that equals 6 times 2, which is 12, so that would also work. Okay. And the last one, go ahead and complete. Not equal to 0, so we're going to make it equal 0. Move that over. Factor it. Greatest common factor between these two things is x. 2x minus 3. You're going to get a fractional answer on this one. Right? I want to know when does this equal 0 and when does this equal 0. Because each of those things would make this true. First, the x part is easy. When that monomial is 0, the whole thing's 0, because I don't care what this would be. That'd be 0 times anything is 0. This part, a little more difficult to do in your head, right? So I'll just write it out. I want to know when does 2x minus 3 equal 0, right? So I'll just solve this. Add 3 to both sides. Solve this for x. 2x equals 3. And divide both sides by 2. So that's 3 over 2. That's an improper fraction. That's okay. If you made it a decimal, it'd be 1.5. I just leave it as a fraction, 3 over 2. So the two answers to this problem, x can be 3 over 2 or x could be 0, and this would be true. So that's kind of a little bit of how factoring helps us solve more complex equations for x.